100 tons of weight feel like nothing when a massive locomotive tears down the rails at a speed exceeding 60 miles per hour. Why did the United States engineer such enormous machines for its rail network? It seems simple to move cargo across a flat surface, but in reality, the American landscape demanded monsters capable of conquering steep mountains and crossing endless deserts. These machines became living legends of rail transportation, though many people today remain unaware that such giants ever existed. The process of building the 10 largest American locomotives in history involved challenges that redefined the limits of mechanical engineering. One can notice how the sheer mass of these engines commands respect, but this is just the beginning. Some of these locomotives were so heavy that they actually caused physical damage to the steel tracks beneath them. The equipment gradually evolved to handle these immense loads, yet the history of their operation is often forgotten. It gets more complex further on. Restoring these legends requires the specialized knowledge of former railroad workers who operated them as far back as the 1950s. It only looks obvious that a locomotive is just an engine on wheels. In reality, some carry names so intimidating that they signal a unique level of power and prestige in the industry. The camera glides along the massive boilers and intricate valve gear of these machines, where one can observe the precision of their construction. Everything only gets more complicated as the scale increases. The final locomotive on this list represents a level of mechanical extremity that changes the entire definition of what is possible on steel rails. Each part of its frame and every one of its driving wheels was designed to push the boundaries of physics. One can notice how the steam and heat once radiated from these steel giants during their peak years of service. The material and engineering transition into the next phase of this historical exploration. 220 tons is the total mass concentrated within the frame and tender of the Milwaukee Road 261. Why was this machine engineered with such immense physical weight during the height of 1944? At first glance, the heavy steel construction seems cumbersome, but in reality, this mass was essential to maintain traction while the boiler operated at a pressure of 250 pounds per square inch. This internal pressure allows the locomotive to generate over 4,500 horsepower, a feat of mechanical force that transformed the Chicago, Milwaukee, St. Paul, and Pacific Railroad during the peak of World War II. One can notice how the 4 leading wheels, 8 massive driving wheels, and 4 trailing wheels work in a specialized 484 Northern type configuration. This specific wheel arrangement was designed for high-speed passenger service across the vast American Midwest, ensuring the locomotive could cover long distances with technical precision. It is visible how the synchronized motion of the side rods translates steam power into rotational force. But this is just the beginning. The locomotive could pull consists of 15 to 20 passenger cars while exceeding speeds of 100 miles per hour. 110 tons of the total weight rests specifically on the locomotive itself to prevent the driving wheels from slipping against the rails under high torque. It seems simple to provide fuel for such a machine, but in reality, the consumption rates required a tender with a water capacity of 24,000 gallons. The equipment gradually feeds fuel into the firebox via an automated mechanical stoker, a system that significantly reduced the manual workload for the crew by eliminating the need for constant hand shoveling. The valve gear system is built according to the Walschaerts design, which remains one of the most respected and reliable mechanical configurations of the steam era. Transition to the next level. The exterior of the 261 is defined by a glossy black finish and polished metal components that reflect the surrounding environment as the engine moves. One can notice the high-pressure steam escaping from the relief valves with a sharp hiss, while the deep, resonant whistle signals the arrival of the train. Everything only gets more complicated when considering the survival of this Class S3 locomotive. Few people realize that this massive assembly of steel nearly faced destruction in the 1950s, escaping the scrapyard only through the last-minute intervention of a railroad employee. Today, the Friends of the 261 maintain the engine in Minneapolis, ensuring the mechanical components remain functional for special excursions. The camera glides along the boiler jacket, where the heat-resistant paint protects the metal from the extreme internal temperatures. The metal remains in an even layer of preservation, allowing the locomotive to draw large crowds during modern rail events. The next locomotive in the series surpasses even this machine in terms of engineering scale and visual impact. The transition to the following stage of rail history begins now. 136 tons of steel and streamlined casing define the Southern Pacific 4449, a machine widely regarded as one of the most aesthetic steam locomotives ever engineered. Completed in 1941 by the American Locomotive Company, this Titan served the Southern Pacific Railroad with a presence that became permanently etched into the mechanical history of the United States. Why was this specific design chosen for the demanding West Coast routes? While a standard engine might struggle with the combination of high speed and heavy passenger loads, the 4449 utilized a 484 wheel configuration to balance immense power with stability. This GS4 class locomotive was built specifically for long-distance service, famously powering the Coast Daylight route that connected Los Angeles and San Francisco. At first glance, the locomotive looks more like a high-speed rocket than a traditional train, due to its vibrant red, orange, and black streamlined bodywork. But this is just the beginning of its technical complexity. The boiler operated at a pressure of 300 pounds per square inch, allowing the engine to generate an estimated 5,500 horsepower. It is visible how the 80-inch driving wheels were designed to maximize track coverage while simultaneously minimizing mechanical wear during high-speed transit. This engineering allowed the locomotive to reach speeds exceeding 105 miles per hour, ranking it among the fastest steam-powered machines ever constructed. The process is only gaining momentum as the internal mechanics are examined. An automatic stoker continuously fed fuel to the firebox, maintaining the intense thermal energy required for sustained high-performance runs. Supporting this massive consumption was a tender capable of carrying more than 24,000 gallons of water to keep the boiler functional over long distances. One can notice the sheer scale of the machine as it moves, accompanied by a deep, melodic whistle that remains unmistakable to any rail enthusiast. It is no surprise that the streamlined silhouette remains one of the most photographed industrial subjects in the world. Everything only gets more complicated when considering the locomotive's life after its primary service years ended. Following its initial retirement, the engine underwent a massive restoration in the 1970s to lead the United States Bicentennial Train in 1976. The locomotive traveled from coast to coast as a national symbol, proving the durability of its original 1941 construction. Today, the machine is carefully preserved in Portland, Oregon, where its mechanical integrity is strictly maintained. It only looks obvious that such a machine would attract historical interest, but in reality, its charisma extended even to the film industry. During a specific filming session on a restricted rail segment, the actor Clint Eastwood once operated the 4449, demonstrating the universal draw of its massive controls and historical weight. The equipment gradually transitions from a functional transport tool to a cultural icon through these high-profile appearances. Even the most famous figures of the era were drawn to the kinetic magic of this specific machine. The narrative does not end at this stage of preservation. One must prepare for the next evolution in rail history, as the upcoming locomotive was pulled back from near extinction through one of the most ambitious and technically difficult restorations ever attempted in the industry. This concludes the overview of the Southern Pacific 4449. Leaving a legacy of speed and engineering precision. 400 tons of total weight represents the staggering mass of the Santa Fe 2926 when fully loaded with its tender. This machine functions as a vessel for both immense physical power and a rare historical rebirth within its heavy steel frame. Built in 1944 by the Baldwin Locomotive Works, the engine belongs to the renowned Class 2900 of the Atchison, Topeka, and Santa Fe Railway. Why were these specific models considered the pinnacle of their era? These units ranked among the heaviest and most potent passenger steam locomotives ever engineered in the United States. Their 484 Northern wheel configuration is integrated with a heavily reinforced frame and a massive boiler pressurized to 300 pounds per square inch. The locomotive alone weighs more than 226 tons, and this density dictated the use of reinforced track infrastructure across its entire operating range. Such weight was not an obstacle, but a necessity for delivering extraordinary pulling power to the driving wheels. One can notice the immense scale of the 8-inch drivers, which allowed the engine to maintain sustained operation at speeds exceeding 100 miles per hour. Even when pulling long, heavy passenger consists across the vast American Southwest, the machine maintained total authority over the desert routes. But this is just the beginning of its technical complexity. Precision in motion was achieved through the installation of the Baker valve gear. This mechanical system provided the crew with exact steam control, significantly improving the overall efficiency and responsiveness of the cylinders. Visually, the 2926 remains an example of pure industrial dominance. The black body, positioned tall headlight, and polished metal details contrast with the exposed moving rods to create the image of a massive mechanical beast. It only looks obvious that such a machine would be loud, but in reality, the specific synchronization of the steam exhaust and the deep rumble of the pressurized boiler create a unique acoustic profile. The equipment gradually transitions from a static state to a rhythmic, powerful motion that commands the surrounding environment. Everything only gets more complicated when considering the timeline of its survival. Retired in 1956, the locomotive spent several decades as a silent, static display in a park. It remained immobile until a dedicated group of volunteers in New Mexico initiated a restoration process that spanned more than 20 years of continuous labor. Today, the engine has returned to an operational state, reclaiming its position as one of the largest working steam locomotives currently existing on the planet. During the initial test runs following its rebirth, the locomotive transitioned through a standard residential neighborhood. A simple recording of that specific moment captured the engine emerging from the modern landscape, appearing like a ghost from the 1940s returned to life. The footage eventually gathered millions of views as the sight of the massive boiler and rhythmic rods moved past suburban homes. The process of its restoration has successfully preserved every technical detail of the original 1944 design. This concludes the history of a desert giant, but the narrative of steam efficiency continues to progress. The next locomotive became a primary symbol of operational reliability during the golden age of steam railroading. This was the Nickel Plate Road 765. The transition to the next level of steam engineering reveals how different designs solve the problems of speed and heavy hauling. One can notice the shift in proportions as the focus moves toward this high-speed freight icon. 808,000 pounds. That is the total weight of the Nickel Plate Road 765 as it stands ready on the rails. Why is this specific machine considered one of the most respected operational steam locomotives in the United States today? Built in 1944 by the Lima Locomotive Works, the engine was originally designed for the New York, Chicago, and St. Louis Railroad. But without the strategic wheel arrangement known as the Berkshire type, this giant would never have achieved its legendary status for speed and stability. The setup consists of 2 leading wheels, 8 massive driving wheels, and 4 trailing wheels to support the weight of the firebox. This 284 configuration ensures that the locomotive maintains excellent traction even when navigating steep grades and sweeping curves. It gets more complex further on. The boiler operates at a pressure of 245 pounds per square inch, which allows the machine to produce approximately 4,500 horsepower. One can notice how the 69-inch driving wheels rotate with mechanical precision. At first glance, the wheels seem built only for raw power, but in reality, they strike a perfect balance between pulling force and high-end velocity. This allows the locomotive to reach speeds of up to 80 miles per hour when the schedule requires rapid freight delivery. The tender behind the engine carries 24,000 gallons of water and 22 tons of coal. An automatic stoker delivers the fuel into the firebox to ensure maximum thermal efficiency during long, uninterrupted runs. Everything only gets more complicated as the engine moves. The sound of the 765 is a distinct mechanical symphony. It is visible how the side rods move rhythmically, accompanied by the deep roar of the boiler and the piercing sound of the sharp whistle. The equipment gradually reveals its rugged and purposeful nature through its polished black finish. Although the railroad retired the locomotive in 1958, the Fort Wayne Railroad Historical Society later completed a meticulous restoration. Since then, the engine has transitioned to a new role, operating public excursions and appearing in film productions as a stand-in for other historic locomotives. The process of preservation is only gaining momentum through these public displays. It seems simple to operate a restored engine, but in reality, every bridge crossing requires careful calculation. One can notice the tension in a lesser-known moment from 1985, when the engine crossed a steel bridge over a century old. The heavy structure shook under the weight, and engineers held their breath as the 4,500 horsepower machine moved forward. The locomotive passed the crossing flawlessly, while spectators lined the riverbanks to applaud the successful transit. But this is just the beginning of the legacy of late-era steam power. Transition to the next level of engineering history. The following machine is a true living relic and represents the final steam locomotive ever built for a major American railroad that remains in operation today. This is the Chesapeake & Ohio 614 Greenbrier. The molten heat of the furnace and the pressure of the steam now pass the torch to the final giant of the coal era. 220 tons is the immense weight of the Chesapeake and Ohio 614, a machine famously designated as the Greenbrier. Why did a major United States railroad order such massive steam power as late as 1948? At first glance, diesel technology seemed ready to take over, but the Lima Locomotive Works engineered this final generation of steam to prove its unmatched capability on high-demand routes. This locomotive was specifically designed to conquer the steep mountainous terrain between West Virginia and Ohio, pulling heavy express passenger trains where lesser engines would fail. The process is only gaining momentum. One can notice how the 4/8 four-wheel configuration provides the necessary stability for such a massive frame. The boiler operates at a pressure of 255 pounds per square inch, allowing the engine to generate 5,000 horsepower. Because the driving wheels measure 74 inches in diameter, the locomotive achieves a precise balance between raw pulling force and high-speed efficiency. It only looks obvious that a machine of this scale requires constant refueling, but the logistics are handled by a massive tender. This trailing unit carries 25,000 gallons of water and 28 tons of coal to sustain the firebox. An automated stoker system feeds the furnace ceaselessly, ensuring that the performance remains consistent across hundreds of miles of track. The camera glides along the refined valve controls and the real-time pressure monitoring systems in the cab, which were considered revolutionary for the late 1940s. Everything only gets more complicated when considering the operational speeds. The Greenbrier is capable of reaching 80 miles per hour even while hauling significant tonnage. Its dark blue finish and gold accents are topped by a high-mounted headlight that cuts through the mountain mist. One can notice the smooth, rhythmic motion of the running gear as the metal rods move in a hypnotic, synchronized cycle, but this is just the beginning of its long history. After being retired in 1956, the engine underwent a full restoration in the 1980s and served as a platform for clean coal efficiency testing during the 1990s. It remains preserved today under the specialized stewardship of Ross Rowland. One of its most remarkable achievements involved hauling 24 passenger cars through the West Virginia mountains without any helper locomotives providing assistance. Transition to the next level. Even competing railroad companies acknowledge the sheer physical power required to move such a consist through high-altitude passes. The locomotive maintains its status as a pinnacle of steam engineering, marking the end of an era before the complete transition to internal combustion. The Union Pacific 844 stands as a living legend in the history of American railroading. Unlike other engines that were scrapped, this steam locomotive has never been officially retired from the Union Pacific roster. It continues to operate as a high-speed passenger engine, representing the final evolution of the 484 Northern type design. The metal lays in an even layer of black paint as the locomotive prepares for its next journey on the main line.